And everyone, again welcome back to my YouTube channel, Engineering Materials and Applications. Myself, Professor Dr. Sandeep Ohol. Today we are going to discuss, or we will start the discussion of the unit number 5, that is the last chapter from this particular subject. In this particular one, we are going to study. Basically, if you see, this is electrical and magnetic materials. That means we are going to study the materials which are used in electrical applications as well as in magnetic applications as well. So here you can see that this is the syllabus for the last unit. This is the syllabus for the last unit, that we are going to study something about the conducting and resisting materials. That means we are going to study something about the conductivity of the material as well as the resistivity of the material. After that, we will see the different types of conducting and resistive materials, their types, their properties and their applications. In the second module, we are going to learn something about the semiconducting materials. Nowadays, we know that India is looking for a very big investment or research in semiconductor industry. So we will also see how these semiconducting materials are there, what are their properties, what are their different types and what are their applications. Then in case of magnetic materials, we are going to learn something about soft and hard magnetic materials and their applications. Then after that, superconductors and dielectric materials, again in terms of their properties and applications. Smart materials are there. Some smart materials are there like sensors. As you guys are going to become a robotic engineer in future, maybe. So for that purpose, you will be in close contact with the sensors, various switches and all that. So we are also going to learn something about different types of sensors which are used, different types of actuators which are going to be used. Again, you will have a more detailed discussion on this particular topic, basically on sensors and actuators, when you go for third year or when you go for final year, as you guys are going to have that kind of specialization. Then we will also see something about the piezoelectric materials, magnetostrictive materials and electrostrictive materials. So this is the content of the fifth topic. We will try to finish it within 7 to 8 modules of this one. So starting with the conducting materials. As we know, everybody knows what do you mean by conduction. It may be a conduction of electricity, it may be a conduction of heat. In terms of electricity, we may say that they are electrically conductive materials. In case of heat, we can say that they are thermally conductive materials. Okay. So based upon, and again conductive means how the material is going to pass a current from one place to other place, or the heat from one place to other place. So basically, if you see, conductors are, in terms of electrical conductors, if you see, it is a substance which is responsible for the flow of electricity. That means if you just take the example of huge cables, in high voltage cables outside that we see, they are nothing but the electrical conductive materials, and they are used to pass the current from one place to other place. Okay. So a conductor, or more specifically, as the unit is more focused about the electrical and magnetic materials, we are going to talk about electrical conductivity rather than the thermal conductivity. Okay. So in electrical conductors is a substance or material that allows electricity to flow through it. Okay. And in a conductor, electrical charge carriers, basically most of the time we see that the materials are made from various electrons and ions and cations and anions. So these electrons or ions are becoming a carrier for that particular electrical charge from one place to other place. So in conductor, basically electrical charge carriers, usually electrons and ions, move easily from atom to atom when voltage is applied. When you are going to apply the voltage, that material or that electrons or ions that particular voltage from or current from one atom to another atom. By that way, they are just passing the current from one place to other place. This is the basic mechanism behind the electrical conductivity. Or if you want to understand the concept of electrical conductivity, we can understand like this that whatever the electronic structure is there, whatever ionic structure is there present in that particular material is responsible for transfer of current from atom to atom, from one atom to another atom, from third, fourth, fifth, like that, when we are going to apply the voltage into that particular material. So that is basically the things. Now the resistivity and the factors affecting that particular resistivity. Now what is resistance? Resistance means that material is not allowing current to flow through that. Okay, that means there is a opposition, there is a force for that particular passage or for that particular movement of the current or passage of the current through that particular material. So resistance, every conductor possesses some resistance. It may be very high or it may be very low. That means the conducting material always it has a resistance. If the resistance is on the peak level, high side, then we call it as an insulator because they are not allowing to pass the current. That's why we say that whenever we do any electrical work in our house on our own, even though we don't know anything about that, but still we try to become hero in front of our family members, and at that same time family members always tell us that just wear the slipper or footwear before doing any electrical work. Why that is needed? Because whatever the slipper, that plastic material you are using for that, or whenever you might have seen that persons, electricians or that kind of persons, they always wear a gloves made from the plastic material because plastic is not allowing current to flow. Okay, so that is insulators. So when there is a tremendous resistance or when there is a complete resistance to the flow of current through the material, in that case that particular material is called as insulator. That means it is not allowing the current to flow. And some of the conductors are acting as there is no opposition at all. Any type of, even the small current is they are able to pass, large amount of current is also there, they are able to pass. So in that case they are called as conductors. In that case they can be considered as conductors. So what is important here? Here again you can see that resistance is effectively helpful in controlling the flow of electric current. So before understanding resistivity and what are the factors affecting the resistivity, we need to understand first what is resistance. So for that purpose I have mentioned one equation over here. Resistance of a material can be measured by R is equal to rho into L by A. Rho is given as a resistivity, then area is the area of the cross section of the conducting material through which the current is passing, and the length of the conducting material. Now from this equation we can say that whatever the resistance offered by the material to the flow of current is always directly proportional to the resistivity of that particular material and the length of that particular material. Directly proportional to resistivity of the material and length of the material. Who is directly proportional? Resistance. Resistance to the flow of current through the conducting material is directly proportional to the resistivity of that particular material and the length of that particular material. Resistivity ज़्यादा है, ज़्यादा resistance आएगा. Length ज़्यादा है, ज़्यादा resistance आएगा. Isn't it? And it is inversely proportional to the area of that particular conducting material because A is in the denominator. So for area, if area is the less area, more conductivity. Isn't it? Less area, more conductivity. Large area, less conductivity. It is inversely proportional. So you can see that from above equation, R is directly proportional to the length of the conductor and resistivity, and the resistance is inversely proportional to the area of cross section of the conductor. So the resistance of the material is affected. So on which parameters? और before जैसे यहाँ पे discuss किया है, before discussing the factors which are affecting on the resistivity, let us first find out what is resistance. So equation of the resistance mentioned here, you can see the image, and that's why you can see this kind of capacitors or resistors in the electronic devices, the small resistors are there. तो उतना लेंथ उसका ज़्यादा होता है, but उसका एरिया कम होता है. Okay, why area is less? Because we need more conductivity. We need more conductivity. That material should pass the current. So you can see this kind of resistors which are there in the electronic motherboard or something like that you might have seen. And here also you can see that length, this area and the resistivity of the material. So basically it is found from this particular equation that resistance of the conducting material to the flow of current through it is directly, it is getting affected by the area of the material through which the current is passing, length of that particular conducting material through which the current is passing, and also the resistivity of that particular material. It is directly proportional to the length and resistivity of the material, but at the same time it is inversely proportional to the area of that particular conducting material. Okay? So now then, what is resistivity actually? So here, electrical resistivity of a particular conductor material is a measure of how strongly the material opposes the flow of electric current through it. As name itself indicates, na? Resistivity to whom? The flow of current. So material कितना ज़्यादा उसको oppose करता है. The ability of a material to oppose the flow of current through that particular material is nothing but the resistivity of that particular material. What is conductivity? Conductivity in that case, it is opposite to that. It is ability of a material to conduct the flow of current or to allow the flow of current through the material. Ability of a material, that is conductivity. So resistivity and conductivity are opposite terms if we consider. Okay. So for that purpose, this particular resistivity is nothing but it is an ability of a material to oppose the flow of electric current through that particular material. So that is resistivity. It is also called, sometimes it is also called as a specific electrical resistance because it depends upon the area, na? So it depends upon the area, that's why it is specific or it, as area comes into the picture, that means volume may also come into the picture. So that's why it is also termed as the specific electrical resistance. This factor enables the resistance of different types of conductors to be compared one another at a specified temperature according to their physical properties. That means we know that depending upon the temperature, the material resistivity may vary. How it will vary? Because when we heat a material, there might be a vibrations at electronic level. That vibrations or atomic vibrations are increasing, and due to that atomic vibration increase, there might be a flow of current. So we have to define the resistivity at certain particular temperature. The material may show different resistivity at different temperatures. Some of the material may show fully resistive to the current at room temperature, but the same material may show conductance at other temperature. So what they are saying that resistivity factor enables the resistance of different types of conductors to be compared to one another at specified temperature according to their physical properties without regards to their length or cross-sectional area. That means here, as in the previous slide we have discussed that resistivity is basically a function of cross-sectional area, length and resistivity of that particular material. But we have not talked anything about temperature at that particular point. Now here, if the temperature is coming into the picture, जब हम वो material कौन सा टेम्परेचर पे यूज कर रहे हैं वो अगर आ रहा है, then in that case it becomes unaffected by the length and the area of that one, because basic reason behind that might be the electronic vibrations or atomic vibrations which are happening at that particular temperature. Why the material? Why whenever we heat any material, as far as ferrous materials are concerned, if we heat the steel material at certain temperature, for example, if we heat ASI 41040 plain carbon steel, at room temperature it is hard, but if I heat it, it becomes soft. So heating, how it is, why it is becoming soft? Because at room temperature, the atomic bonding at atomic level, the bonding between the atoms might be rigid one, might be strong one, but due to the heat which is supplied to that particular material, material, that heat may be responsible to weaken that forces, atomic forces in between the atoms or bonding between the atoms, and that's maybe the reason why the material is becoming soft. Okay. So here also, in case of conductivity also, electrical conductivity also, it is possible that at room temperature your vibration of the atoms or electronic vibration at atomic level may be less, but when we heat that particular material, this vibration may increase, and that's why there might be a more flow of current. So based upon, if we think about the temperature, in that case, whatever the factors, initially we have discussed that area and length of the conductor, they becomes little bit important when the temperature comes into the picture. So thus higher the resistivity value of rho, the more resistance and vice versa. The material is, if having higher resistivity, then there is no passage of current, and if it is having less resistivity, more passage of current. That means high resistive material will act as an insulator because there is a higher resistance to the flow of current, and low resistance material may act as a conductor because there is a less resistance for the flow of current through the material. I hope you guys are getting what I am trying to say. Then next parameter is conductivity. This symbol is called as conductivity. Sigma is the reciprocal of electrical resistivity of the material. Quite obvious. The material which is conductive for electrical current will be having a less resistivity. That means conductivity and resistivity are opposite to each other, or you can call it as inversely proportional to each other. If the material is having more, if we say that material is conductive, that means its resistivity is low. If we are saying material is resistive, that means its conductivity will be low. So it is sigma equal to 1 by rho. It is the property of the material due to which the electrical current flows easily through the material. In other words, it provides ability of the material or to the material to flow the electric current through the material. If you see the classification of the conducting materials, they are classified as low resistivity materials and high resistivity materials. That means this I can call it as a conductive materials because their resistivity is low. This I can call them as a resistive materials as their resistivity is high. So here you can see that some house wirings are there, then power transmission is there, then some windings, motor windings or something like that, that we can call it as a low resistivity materials. Now high resistivity material example is heater, water heater or any heating element. Okay, why heat is getting created? How heat is getting created? When I am passing the voltage through that particular material. When I am passing the current through the material, then the flow of the current is getting opposed by that particular material, and due to that opposition, heat is generating. So that's why these materials are nothing but the heating elements are there, some starters are there, some resistances are there, some filaments are there. Light ka bulb, we will take the example of light bulb, and there is only small wire, tungsten wire is there. When we are just switching on that particular button, it heats up, and whatever the light we are getting from that one, that is due to the resistance to the flow of current through that particular wire. If that current goes beyond some value, apan manto bulb gaya. Likewise, the traditional bulb, you might be knowing that yellow light color bulb. Okay, so that small wire, it is, if the overcurrent is there, it will get break. Okay, so that kind of wires are called as a high resistivity materials, and the wires which we are using for making switches and all that, or any house electrical work and all that, these wires are also able to pass the current, but they are not getting heated up. They are not getting heated up. They are not getting. They are not resisting the current of flow as this heating element is resisting the current of flow. Okay. So just try to get the difference between these two. Low resistivity materials means the electrical wires or this kind of cables through which we are passing the current from one, or just switches, the yellow colored or red colored or black colored wires are there. Again, colors are not given that like ki unko acha lagta hai wo color. It is not like that. There is a color sign conventions are there. Some for earthing, I think black colored wire is always going to be used. Earthing के लिए कौन से कलर की वायर यूज होती है? As per my knowledge, it is black. I don't know exactly, but you just check it. So what I mean to say that whatever the color convention is used over there or color signs are used over there, they are for some purpose, not for the type bars. Okay, so that kind of wires we can call them as a low resistivity. They are going to have a resistance to the current, but the amount of resistance will be on a very lower side. And high resistivity wires, that means a kind of water heater, okay, or any nichrome wire which is used as a heating element. Just we have to give the voltage and current to that particular wire, it will get heated up. So that why it is getting heated? Because they are having very high resistance for the flow of current. All applications where power loss and voltage drop should be low. Examples given: transmission of power from Mumbai to Pune. Like हमारे जो cables है, high current carrying cables, towers देखते हैं हम लोग, towers. They are connected with the help of cables. From them also the current is passing, but we haven't seen that any wire is getting red hot at certain point. Because why it is not there? Because the power losses are less during the transmission phase. Their voltage drop is also less. That's why they are not, and that's why these are transmission of they have used for the transmission of power from one place to other place. Materials used for this particular wires are copper, aluminum, and silver. So you may have seen in motor rewinding. कोणी शेतकरी असेल तर त्याची मोटर गेली म्हणजे काय होतं? मोटर जळाली म्हणजे काय होतं? What happens? The motor burns means what? That wiring gets short circuited. We need to change that wire. So if you have seen that brown colored copper wires, a bundle of copper wires is again rewinded into that rewinding. That's why motor rewinding it is called as. And that is one of the examples. Then aluminum wires are also there. Then some silver wires are also used for this. Now in this case here, you can see that high resistivity materials. All such applications where large value of resistance is required. If low resistive materials are used, the length of the wire would be too large. In this particular one, for that heater, if I use the low resistivity material, my heater wire will be, or that windings of that heater will be too large to get that much of heat, or to get the water heated within 10 or 15 minutes. Okay, but you can see that they are only having 3 to 4 circles like that, or rounds in that, and it is hitting the water within 10 to 15 minutes up to required hot temperature. Okay, so that we can use here the low resistivity material, but the length of that particular material will be more, because again resistivity is directly proportional to the length of the conducting material. अगर मुझे रेजिस्टिविटी ज़्यादा चाहिए तो लेंथ भी ज़्यादा लगेगी, रेजिस्टिविटी कम चाहिए तो लेंथ भी कम लगेगी. तो यहाँ I hope you guys are getting the meaning of this sentence, that if low resistivity material are used, if I use the low resistivity material for high resistivity material application, that means if I replace, हमारी इंडियन मेंटालिटी होती है ना, जो सस्ता है वो उससे काम चलाएंगे. But in that case, if we do like that, we need more length of the wire. Again, due to the again as per the definition of resistance, we need more wire. So for this high resistivity materials, we have to use the wire which is having high resistivity, because length will be less in that case. So for example of this particular high resistivity materials are nothing but the nichrome wires. Now just more about this one, low resistivity materials. Apart from low resistivity, the material should have following properties. This low resistive material, the main property that the resistive material should have, that it should have low resistivity. That means it should flow more current through that particular material. That is the first basic property of the low resistive materials. Apart from that, what other properties are required? Low temperature coefficient. That means the change of resistance with the change in temperature should be low. If the temperature is changing, if the fluctuation is there in the temperature, at that time your resistivity should not change according to the temperature. That means there should be a fluctuation, but that much fluctuation is not required. So that's why low temperature coefficient. There should not be a large change in the resistance with the change in temperature. This is necessary to avoid variation in voltage drop and power loss with changes in temperature. So if this low temperature coefficient is there, that means you will have low power losses during the flow of the current or transmission of the power from one place to other place. The power losses will be less, voltage drop will be less if your low temperature coefficient material is there. Low temperature coefficient means what? There should not be a large fluctuation in the resistance of the material due to the fluctuation in the temperature. Due to the change in temperature, your resistance should remain constant or try to able to remain constant even though there is a change in temperature due to the operating conditions. So that means again your resistance of the material should be low sensitive to the change in temperature. I hope you guys are getting. It should be low temperature sensitive. Temperature sensitive कम होना चाहिए. Then example दिया यहाँ पे उन्होंने. The resistance of a transmission line which are very long will increase when exposed to the summer sun. पुणे से मुंबई में power transmission transmit कर रहा हूँ and nowadays summer days are there. So that effect of temperature around 45 degree temperature is there nowadays. 44-45 degree temperature. That temperature effect should not be there on that wire. Otherwise what will happen? More power losses will be there, more voltage loss will be there, and whatever the amount of power transferred from one place to another place, that may not be adequate, that may not be sufficient. So the resistance of transmission line which are very long will increase when exposed to the summer sun. This will cause increase in voltage drop, this will cause increase in power loss. So आपका loss हो सकता है उसमें. Mechanical strength. To bear the mechanical loading, example overhead wires or winding loads or windings. So ऊपर वाले जो whatever the wires which are going from one pole to other pole, they should have also mechanical strength. बीच में किधर टूटना नहीं चाहिए. So that mechanical strength is also required. Ductility, that means it should be flexible. It should not be rigid in that case. Then shoulderability, that means as far as joints are concerned, sometimes I need to give the joints. So it should get shouldered easily. Okay, if it is not getting easily, that the joint should offer minimum contact resistance. मुझे power flow करना है ना, तो joint अगर मैं ऐसा करूँगा कि वहाँ पे joint की वजह से resistance बढ़ना नहीं चाहिए. Resistance should not increase due to the joint. So when I am going to do the joint by welding or something like that, there is a possibility of increase in the resistance. That means again your voltage drop, power loss is there. So what we are going to do in electronic devices, you might have seen, they are not doing any capacitor or resistors. They are not always welded on that motherboard or any base for that. They are always shouldered. I hope you guys have imagined the soldering process. देखा होगा आपने कभी कोई भी कैपेसिटर या आईसी कनेक्ट करना है तो ये एल्यूमिनियम काइंड ऑफ वायर इज गेटिंग इंसर्टेड एंड इट इज द टॉर्च व्हिच इज हीटिंग टॉर्च इज देयर, इट इज डायरेक्टली getting melted over there and after some time it gets solidified. That is soldering process. So if you have soldering in that, then the joint resistance or contact resistance will be on the lower side and that will be useful for minimum contact resistance. A simple joint would be a twist the conductors with the material to which it is to be joined, but this gives high contact resistance. Minimum contact resistance results if the joints are shouldered, and resistance to the corrosion. Conducting material should be such that it is not corroded when they used in outdoor atmosphere. So whatever the wire materials we are using, usually you will see that it is not getting corroded due to any effect like water during rainy season, like temperature during winter season, low temperature during winter season, or high temperature during summer season. And this last slide I would like to cover high resistivity materials. So apart from high resistivity, low temperature coefficient, again here high resistivity material are often used as shunt in electrical measuring instruments. What do you mean by shunting? I hope you guys have learned this in electrical machines. What do you mean by shunting? And again here it is written that electrical measuring instruments. So if I want a low current for electrical measuring instrument, whatever the extra current I can bypass. Shunting means making the bypass flow of the current. Okay, so high resistivity material are often used as a shunts in electrical measuring instrument in making wire bound precision resistance and resistance boxes. So for such precision applications, an important requirement is that the material of the element should have negligible temperature coefficient of resistance, as otherwise the accuracy of the measurement will be reduced. That means whatever the material you are using in that particular measuring instrument, that material should have a low coefficient of temperature coefficient, because if it is more, you may not have the precise readings in that. So to get the precise readings, even if the material is not that much of low temperature coefficient, we can use the shunts in between so that they will bypass the extra amount of current in that, and whatever the purpose of that particular measuring equipment like ammeter or voltmeter, okay, you are using that one for checking the voltage across the 2 points. So that kind of instruments will be helped. If you are using the high resistivity material in that, you have to take care of this low temperature coefficient by making shunts in that particular circuit. Then high melting point should be there. Now as these are used as a high resistivity material, for example heater is there, heater is getting melted out instead of getting heated up, our purpose will not be solved. So whatever the material you are using for as a heating element, that material should have high melting point. So heater जब आप बाहर निकालते तो almost its temperature might be more than 1000 degrees Celsius. So the material used for that particular application, it should have high melting point so that it should not getting melted up when there is a huge resistance to the current through that particular material. Application like loading rheostats or starters for electrical motors, the material of the resistance element should be able to withstand high temperature for a long time without melting. No tendency for oxidation due to the heating temperature, due to the resistance, high resistance to the flow of the current, heat is generated, and if that material is open to the atmosphere, it should not get oxidized. That means it should not get react with the atmospheric oxygen and forms the oxidized layer on the surface, so that it will have no tendency, or it should have high oxidation resistance as well. Used for high resistance element in heating appliances should be able to withstand high temperature for long time without oxidation. Then ductility is one more, and then mechanical strength is one more. So in the examination, you may have questions on this, that define the resistivity of the material and resistivity and conductivity of the material, or I can have a question like explain resistivity and conductivity of the material. So for that you have to write this kind of explanation for the same. Explain resistivity and conductivity in the electrical materials, because we are specifically talking about the electrical materials. Then you can just give the classification of conducting materials with suitable examples. So this slide is sufficient for that. Then explain low resistivity material, properties of low resistivity materials, properties of high resistivity materials. Explain properties of low resistivity materials and high resistivity materials. Thank you very much.